Okay, so today we are going to discuss about generic ARM architecture. So, of course, there are many ARM microcontrollers and processors, and they have different architectures. But usually, all these blocks can be found in almost all the ARM processors. And of course, if you want to go in detail about a specific architecture, you can always look at the data sheet and the guide for that particular ARM microprocessor, right? So if you see, this is quite similar to the block diagrams that we have covered before, whether for MSP 430 or 8051 or 8085. We have certain number of blocks available here. So let's go through some of these blocks one at a time. So first we are going to discuss the ALU, that is the arithmetical logical unit. So ALU has 32-bit inputs, two 32-bit inputs. The primary comes from the register file, whereas the other comes from the shifter. So you can see here ALU. So one of the input comes from the register file, while the other input comes from the barrel shifter. We'll discuss this in a while. The status register flags are modified by the ALU outputs. ALU has a 4-bit function bus that permits up to 16 opcodes to be implemented. So here the status flags are stored, and the status flags are modified obviously according to the ALU operation as it is there, and we have seen in previous microprocessors as well. Then let's come to the booth multiplier. ARM microprocessor basically uses 32-bit booth multiplier for multiplication. So this is nothing but a multiplier, but a specific type of multiplier that uses a booth multiplication algorithm. So we don't have to do this in detail, but for those who are interested and who want to read a little bit more about this, you can definitely check the booth multiplier algorithm. Next, let's come to the barrel shifter. The barrel shifter is a functional unit which can perform 5 different kinds of shifting and rotating operations, that is logical left shift, logical right shift, arithmetic shift right, and rotate right extended. So barrel shifter एक नया ब्लॉक है जो आप लोगों ने पहले कभी नहीं देखा होगा. So it is quite unique to ARM. So it is used for different kind of shifting operations. Then talking about the control unit, it sends control signals to different components of the processor to control their operations. This we have studied in different processors as well as peripherals. MAR, the memory address register. So basically, what is this register? It contains the address to the memory location being accessed, just like a program counter. But it is not a program counter, but जो भी memory location access हो रही है, that is stored in MAR. Then MBR, that is the memory buffer register. Register in a computer's processor or central processing unit, that is the CPU, that stores the data being transferred to and from the immediate access storage. Next, let's talk about the address incrementer. It is used for incrementing the address pointer. Address pointer means जो कि memory को point कर रहा है. Which memory location are we accessing? Then registers. Obviously, every processor or a controller has a bank of registers. So the amount of registers again depend on the ARM version. So I've been telling this since the beginning. A lot of things might change considering different ARM architectures. But according to the reference manual from which I have taken this data, there are 30 general purpose 32-bit registers available in almost all the ARM architectures except ARM v6m and ARM v7m. The first 16 registers are accessible in user level mode. The additional registers are only available in privileged software execution mode. So user level mode जो general programming है, in that you can only access the first 16 registers, that is R0 to R15. तो हम अभी user level mode और in first 16 registers की ही बात करेंगे. So the first 16 registers are actually split into two groups, the GPRs, that is R0 to RL, and special purpose registers R12 to R15. Right? R12 to R15 may be used as general purpose registers अगर वो किसी और फंक्शन के लिए यूज नहीं हो रहे, बट बाकी सारा काम आप R0 to R11 में कर सकते हैं, and R12 to R15 will be used for special purposes. So let us have a look at all these registers. So ये मैंने R12 to R15 यहाँ पर आपकी जो SPRs हैं, special function registers, SFRs, I have included them here. So if we talk about R0 to R12, firstly, they can be used during common operations to store temporary values, pointers. For example, R0 can be also referred to as accumulator during the arithmetic operations or for storing the result of a previously called function. R7, for instance, becomes useful when we are working with system calls as it stores the syscall number, and R11 helps us to keep track of boundaries on the stack. Moreover, the function calling convention or ARM specifies that the first 4 arguments of any function are stored in the registers R0 to R3. So apart from the general purpose functionality, ये कुछ specific functionalities हैं जो कि आप R0 to R12 में use कर सकते हैं, right? Talking about R13, that is the stack pointer. The stack pointer, we already know what a stack pointer is. Every processor has a stack. So the stack pointer points to the top of the stack always. The stack is in the area of a memory which we use for a function specific storage and which we can reclaim whenever the function returns. Stack, हमें पता है, it can also be used for general data storage based on LIFO, last in first out, right? Then talking about R14, that is LR or the link register. When a function call is made, the link register gets updated with the memory address referencing the next instruction where the function was initiated from. Doing this allows the program to return to the parent function that initiated the child function call after the child function is finished. So if we are calling another function that is called the child function from a parent function, तो वहां पर आपका लिंक रजिस्टर यूज होता है. It gets updated with the memory address referencing the next instruction where the function was initiated from. So it will store the address of the next instruction from where the parent function called the child function, right? And then coming to the program counter, the program counter is same in all the architectures and processors. So it will actually store the address of the next instruction to be executed, right? And it is incremented by the size of the instruction executed. This we have seen several times in different processor architectures. In case of ARM processors and ARM architecture, the size is 4 bytes in ARM state and 2 bytes in thumb mode state. तो ये अभी हम डिटेल में पढ़ेंगे बाद में. आपके दो इंस्ट्रक्शन सेट्स होते हैं इन केस ऑफ आर्म, एक तो नॉर्मल जनरल आर्म होता है एंड एक थंब इंस्ट्रक्शन सेट होता है. सो द साइज ऑफ द इंस्ट्रक्शन विल डिपेंड ऑन विच इंस्ट्रक्शन सेट वी आर यूजिंग. When a branch instruction is being executed, the PC holds the destination address. During execution, the PC stores the address of the current instruction plus 8, that is the 2 ARM instructions in ARM state, and the current instruction plus 4, 2 thumb instructions in the thumb state. So ये हमारा जो architecture है, it is slightly different from the x86 where PC always points to the next instruction to be executed. जो हम लोगों ने अपने previous architectures में देखा है, वहाँ पे PC always points to the next instruction to be executed, but here it is slightly different in ARM. So you can see here in case of your normal ARM state, PC कैसे बिहेव कर रहा है, what will it store, and thumb state में ये क्या store करेगा. So not just the address of the next instruction to be executed. Alright. So this is all about your ARM generic architecture, because we have only one topic of this concept. So I'm not going into very much detail because इतना आपके syllabus में cover हो ही नहीं सकता और आएगा भी नहीं. But yes, you should understand all these basic elements. ये basic blocks क्या क्या है, क्या क्या करते हैं, and a little bit of information about the register bank. तो register bank का question अलग से भी आ सकता है, not only included in the ARM architecture.